Elon Musk is well known for taking on challenging endeavors, and his most recent endeavor is no exception to this rule. Musk has been hard at work on a light-speed engine that, according to him, has the potential to transform the way that people travel through space by allowing spaceships to travel at amazing speeds and, as a result, potentially arriving at other star systems in a matter of years rather than decades. Although the idea of a light-speed engine has been around for quite some time, Musk's method to solving the challenge is novel. The majority of hypothesized light-speed engines are based on theoretical physics notions such as wormholes or warp drives. These concepts are still considered to be speculative because their existence has not been confirmed. On the other hand, the engine that Musk developed is predicated on more well-established scientific principles. Musk's engine is based on the concept of using a sequence of intense lasers to heat and compress a small pellet of fuel, so causing it to go through a nuclear fusion reaction. This is the fundamental theory underlying the engine. The result of this reaction would be the release of an enormous quantity of energy, which, if harnessed, might be used to move a spacecraft forward at extremely high speeds. Inertial confinement fusion, sometimes known as ICF, is the name of the technology that powers this engine. As a possible future supply of power, ICF has been the subject of research for many years. To induce fusion reactions on a big enough scale to be beneficial for space travel, however, has proven to be a difficult task. The difficulty has been to devise a method that is both feasible and effective. Musk's strategy involves concentrating the energy of a number of lasers onto a very tiny target, which would then be compressed and heated to the point where it would undergo fusion. The surge of energy that is produced as a byproduct of this process would then be utilized to move a spacecraft ahead. The process would be carried on indefinitely, resulting in a constant stream of propulsion that, over time, might eventually achieve speeds equal to as much as 10% of the speed of light. This method does not necessitate the use of any unusual components or abstract ideas from theoretical physics, which is one of its most significant advantages. The fact that the technology is based on well-established principles of nuclear physics and laser technology indicates that its implementation in the not-too-distant future is more likely to be successful. However, there are still a lot of technological obstacles that need to be conquered before an ICF-based light-speed engine can become a reality. Compressing the fuel pellets to the required levels without causing them to break apart or lose their shape is one of the most difficult tasks, and it is also one of the most important problems. Concerns have also been raised over the quantity of energy that would be necessary to power the lasers, in addition to the potential dangers that would be posed by the act of handling and storing the fuel. In spite of these obstacles, Musk continues to have an optimistic outlook regarding the possibilities of a light-speed engine. He believes that it has the potential to usher in a brand new era of space exploration, one in which we are able to travel to other star systems and perhaps even populate planets outside of our solar system. It is yet unknown whether or not this visionary concept will ever be brought to fruition, but the possibility that it will does present an intriguing opportunity for the development of space travel in the near future.